Learn these three rules. If you have a base to an exponent inside brackets raised to another exponent, what do you do with the exponents?
Add them.
Multiply them.
Same thing.
It's not.
Unless it's like 2 and 2. I'm pretty sure it's not.
A to the m times n. So you multiply the exponents. If it's two terms inside brackets with an exponent outside, where does that exponent go? It goes to both of them. And if you have a fraction to an exponent, where does the exponent go? Both of them. Okay. Sorry? That's this. Same thing. Yeah. Okay. So, -6 times 4 all squared. There, you now have two ways to solve these types of things. And we're going to look at when you want to do one versus the other. But what are the two ways to solve this? What's one of the ways? What should we do? Yep. You just follow BEDMAS. Yeah, exactly. So -6 times 4 is -24. If you square -24, do you get a positive or negative number?
Yeah. Positive.
Positive, right?
Yeah.
If you square a negative number, you get a positive number, and 24 squared is 576. All right. The other way to do it is that -2 would go to both numbers inside. This seems like, why would you do it this way? There are advantages to doing it this way. -6 squared is 36. 4 squared is 16. 36 and 16 is 576.
Yes.
Okay. What if we have, we'll just do a division one here.
B.
24 divided by 6, all to the 4th power. That can also be written this way. Those mean the exact same thing. All right, division is the same as writing it 1 over one another one. Now, what's one way to do it? What would you do if I gave you this question on a quiz, which I will? Addison, sorry. Willow. You'd solve in the brackets, which is a completely legitimate way to do it. 24 divided by 6 is 4. 4 to the power of 4 is 256. The more complicated way, which I kind of dropped the hint, I wouldn't normally do it this way, but you could, is you could write it as 24 to the power of 4 over 6 to the power of 4. But you're dealing with big numbers here, right? So nobody really wants to do this. But if you did it this way, you'd get 33,1776 is 24 squared, or to the 4th. 6 to the 4th is 1296. And if you divide those, you get 256.
Yes.
So you get the same answer no matter which way you do it. I tend to think this is the easier route. Solve what's inside the brackets first. All right. So I don't know if this is a rule, but a helpful tip. How about that? Tip. Boom. when the numbers inside the brackets are different, simplify first. So that's what we did up above. So when the numbers are different, for example, 24 and 6 are different numbers. So I simplified inside the brackets before I did the exponent. Okay, that's usually the faster way. If the numbers or the base, more importantly, when the bases are the same inside the brackets, then I would use exponent laws. Okay, so let's put an example here. So if we have 3 times 2 to the third, I would simplify what's inside the brackets to get 6 and then raise it to the power of 3. I don't know what 6 to the power of 3 is. Please stop doing that. Pacey. 216. Okay? But if you have when the bases inside the brackets are the same or equal, then use exponent laws to simplify. So we'll do an example of that. Stop it. So we have, I'll wait till everybody copies this down. A lot of 3s and 4s.
There's only 2 4s. Without the answer. Easy.
Okay, so bases inside the brackets are the same. So we're going to use our exponent laws to simplify. If the bases are the same, what do you do with the exponents when you're multiplying? You add them. So this, the first bracket becomes 3 to the power of what?
7. Wait.
5 inside. And then it's all raised to the power of 3. Minus. Same with the second set of brackets. 4 to the power of 5, all squared. Then we can use, I'll bring it back down in a sec. If you have an exponent raised to another exponent, you multiply the exponents, right? So what does this become? 3 to the 5 times 3. What does that become? 3 to the 15. What does the 4 become?
4 to the 10.
4 to the 10. Now, there are no rules for when you're adding or subtracting. Okay? So now we just literally have to put this in our calculator, which is going to be a gross number. But I know what it is, so you can just copy it down. 3 to the 15 is 14,348,907. 4 to the 10 is 104,8576. So if you subtract them, you get 13,331.
I got that in my head.
The important part is from here to there. Okay? Simplifying it first. Now you could go 3 squared is 9, 3 cubed is 27, 27 times 9 is whatever, raised to the 3, and da 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 da.
This seems a lot easier.
It is. All right. Example number 2. Three times 2 squared plus 3 to the 8 divided by 3 to the 6, all squared. All right. First bracket. Are the numbers the same? No, they're not. So you can combine them. All right. What's 3 times 2? 6. So I get 6 squared plus. Now, second bracket, bases are the same. So we have to use exponent laws. If you are dividing, what are you doing with the exponents? Subtracting. So what does the second set of brackets become? 3 to the power of 2, all raised to the power of 2. All right. And then what's 6 squared? What's 6 times 6? 36. What does the second set of brackets become? 3 to the power of 4. Anybody know what 3 to the power of 4 is? It means 3 times 3 times 3 times 3.
91. No,
81. 81. And then just add them together. Okay. So simplify the brackets. If the numbers are different or the bases are different, in this case, it makes sense to combine them, like do that operation. If they're written as the same base, use your exponent laws to simplify first. One more and then we're done. No. No. C. What is the answer?
1.
Why is it 1?
Everything is to the power of 0.
If everything is in brackets, it doesn't matter what's going on inside the brackets. If it's raised to the power of 0, it is equal to uno. Yes. All right, here's your questions. Books are up here. Page 84, numbers 14, 16, 17, and 19. No? You have one quiz tomorrow.